In this way we have calculated the value of T2. So till now we have discussed how to calculate the enthalpy, how to calculate the entropy. Now from equation number 1 we can calculate the H2. So H2 is equal to H2 dash, that is a 368.67 plus 0.76, which is Cp, plus into T2 minus 313. T2 that we have calculated 317. So therefore value of H2 is equal to 372 kilojoule per kg. Value of H2 is equal to 372 kilojoule per kg. Now, so if H2 is known, H3 is the point 3 is on the 40 degree Celsius line and it is on the liquid line. So therefore H3 value is 239.29. As we have shown here, point number 3 lies on the saturated liquid line, and that point number 3 is corresponding to the condenser pressure. Our condenser temperature is 40 degrees Celsius. Hence we have to check the 40 degrees Celsius temperature and its property at saturated liquid. So that H3 is 229.39. Sorry, H3 is equal to 239.29. So now H4 is given, H4 is calculated, H3 is equal to H4, and H1 is also calculated. So therefore total refrigeration effect is observed during process 4 to 1. So therefore total refrigeration effect is equal to MR into H1 minus H4. But here refrigeration effect, that is already given, kilowatt per TR. Per TR means 3.5, that is already given. H1 that we have already calculated, H1 is equal to 354.64 and H4 is 239.29. So by using this calculation we can calculate the mass flow rate of a refrigerant. So mass flow rate of a refrigerant is equal to 0.031 kg per second. 0.031 kg per second. Now the theoretical piston displacement per TR. Theoretical piston displacement per TR. Piston displacement, when the piston is moving up and down, what will be changes into the volume. So if we can calculate the volume, we will get the piston displacement. So therefore the volume of suction vapor V1 is equal to mass flow rate into specific volume, MR into specific volume. Now it is regarding with the suction. Suction is at the evaporator pressure. So therefore at 45 degrees Celsius the specific volume is 0.04781, because we are calculating the volume of suction vapor. Suction takes place during process 4 to 1. So during that process, that is regarding with the evaporator pressure. So here we have to take the specific volume corresponding to the evaporative temperature, and the evaporator temperature is 5 degrees Celsius. So therefore the specific volume is 0.04781. So therefore V1 is equal to mass flow rate is 0.031 multiplied by 0.04781. So if we are taking the multiplication, we will get the volume is equal to 1.457 into 10 raised to minus 3 meter cube per second. 1.457 into 10 raised to minus 3 meter cube per second. So suppose if we are taken multiplied divided by the 60, you will get into the minute. So therefore 0.874 meter cube per minute. Now the theoretical power per TR. Now power is equal to W is equal to MR into H2 minus H1. So mass flow rate is calculated 0.031, H2 the value is 372 minus H1 is 354.64. So therefore the theoretical power per TR is equal to 0.538 kilowatt, 0.538 kilowatt. Now last term that we have to calculate, that is the COP, and we know the COP is the refrigeration effect divided by work done or power required. So COP is equal to QA divided by W, or it here refrigeration effect divided by power. So refrigeration effect is 3.516 divided by power is 0.538. So if we are taking the division of this, COP is equal to 6.53. COP is equal to 6.53. So please remember the point. Here we are calculated the first. Please remember the two formulas. H2 is equal to H2 dash plus Cp into T2 minus T2 dash, where 2 dash is the point on the saturated curve, and S2 is equal to S2 dash plus Cp into ln of T2 upon T2 dash. So if you can remember these two formulas, so is it easy to calculate the, or is it easy to solve the numericals on the vapor compression refrigeration cycle.